Hello, today we're going to talk about building an Altera MAX10 device using the Altera physical flow. When we use the Altera physical flow, we need to get a pinout file from Altera. And if we go to the altera.com support page, we can find the pinouts, and they have all the pinouts in one place, documentation pinout files. We explode the MAX10 and then we look for the device we care about. So in this case we're doing the 1008 DC, so we load that, and if we go back we can also save it as a file. So I saved that as a file, the 10M08 DC file, and then I'm going to use that as the input for this design. So when we set up, we're going to build the 10M08. I created a new directory for it, a 10M08 DCF 256A7C. We select the Altera physical flow, and then we browse to find the text file, and that we copied it local into that directory already. So we have the 1008 DC. So now we're ready to read the pin report. Let's clear the status from when we did. And when we read it, it's going to say there's an error detected in the pin step report. And if we look here, it said there's no Altera family selected in the control file, and we need to select the Altera family and the Altera package in the pinout report. The reason is these Altera files contain pinouts from more than one device. So when we open this more config device, the Altera family is auto-detected when it reads it, and then these were the devices that were the packages that were found in there. So I know we're trying to use the F256 device, the 256 pin BGA, so we select that, and then we can save the minimal config settings, and we say no to this save, and then we read the pin report again, and now it read it, it went green, and let's see what happened. So when it read the pin report, SmartFrac ran, and it detected that this is an FPGA type device, and it detected there was a bank 1A, 1B, 2, 3, 4, 5, 6, 7. So SmartFrac creates a very compressed symbol description language file for us, and all we have to do is place 9 signal match statements matching 178 signal pins and 16 power match statements matching 78 power pins for a total of 256 pins. So, and then what it did is it created this SDL from template.sdl file that we can go edit. So I'm going to open that up and we're going to take a peek around in here. So when we're using a template file, the first thing we want to do is say, once we like the template, so once we get the pinout read in the way we want, and if we had to do any pin renaming or anything like that, we would set that up first, and then let SmartFrac build this file. But once we like it, let's save it as symbol order.sdl. And then that way when SmartFrac runs in the future, it won't overwrite it. So this is new SDL file, and symbol order is different than the currently selected symbol description. Do you want to change the sim control? And we say yes. So now the symbol description file that Part Builder is going to use is this, what we just renamed. When SmartFrac builds a template, it puts all this extra information in. I find that most people don't even use it, so let's do a Control-click and Control-X to delete it. And now we're left with just the SDL that we wanted. And you know what? Let's put that back for a second. Control-V, and we're going to take this and delete it, just those comments. You can notice I pasted the comments underneath the start of a symbol. So what I wanted is to show what PLD information that SmartFrac found. So it found banks 1A, 1B, 2, 3, 4, 5, 6, 7, and 8. As you can see, SmartFrac is very intelligent, so it built a symbol for bank 1A, bank 1B, bank 2, bank 3, bank 4, bank 5, 6, 7, and 8. What I want to do is take all the VCCIOs and move them to that bank. So I'm going to search for VCCIO, and I'll select all. And then I'm going to merge them to that spot, and then I'm going to cut it, and then I'm going to move them up here and distribute them. So in this case, I just want to put the VCCIOs on that bank. So this is bank 1A, so I'm going to do Control X, Control V, and I'll put that on the left. And why don't we put all the VCCIOs on the left first? So we select them all. We can use the set side for selection. We could choose whatever side we want. Left, okay. So now VCCIO 1B is next, so we'll Control X, and we'll move that into the 1B bank. Control V. So now they're going backwards, 2, 3, 4, 5, 6, 7, 8. So Control X, the VCC2, Control V, and then let's Control X. Let's move them all at once so we can see what we're doing. Control, so we got VCCIO2, we need VCCIO3. So now VCCIO3 is on the left, and we'll move the rest of them down. That's probably the easiest way to do it. Let's move them down. That's one way to do it. So now VCCIO4 is there. We'll do a shift click. So Control X. Now I'm going to move VCCIO5 here. Control V. And then we're going to move 6, 7, and 8 down. Or do we want to just do it? Let's move 6. Control V. So now that we can see, let's move 7. Just bank 7. And then let's move 8 to bank 8. Let's go back and look at the bank we created. So bank 1A, what SmartFrac did is it created this special match statement to find any pin that's in bank A. And when SmartFrac ran, it also sorted the pins in the order that they appear in the bank, so that when we use this pin match, we're going to get the pins in the right order for each bank. So this is all we need to describe an IO bank. Okay. And now the next job is to just fix the ground pins. So what I'm going to do is I'm going to take the ends, the no connect pins, I'll move them to the bottom. I'm going to put the grounds on the right, and I'll move that up to the top. And then I'm going to distribute the power on the left. So I'm going to take VCC 11 to 1, I'll move that to the top. So that's got the most pins. And we're going to put all of these on the left. And we can use this set side to the left. Say OK. And then what we want to do is put a spacer between them on the left. So we're going to use the add left spacer, which is also a shortcut of Control L. And I'm going to put 2 spacers. So I'm going to make it a bus 1:0. And then I'm going to copy this spacer, Control C, and I'm going to put it between each rail, Control V, Control V, Control D. And then I'm going to put a balance symbol sides in front of the no connect pins. And I put 2 by mistake, so I'll delete it. And then we'll put this on the right side, the no connects. And now we've done all the work we need to do to place the part. So we'll save it, and then we'll click Build Symbols. And we could take a look at our symbols. We view the Allegro HDL symbol. And so here we go. We got the bank 1A, and I put, you can see the IO 1 to 16, so SmartFrac sorted that for us and did all the work we needed to do to sort these pins in the right order. There's VCCIO-B, there's VCCIO2, there's VCCIO3, VCCIO4, 5, 6, 7, 8, and then here's the power. So we put the VCCs on the left, we put 2 spacers, the VCC-D, 2 spacers, and then the grounds just went automatically. And then we had put a balance symbol sides, so the NC ends up over here. Now let's go back to the first symbol. There's not that many pins on here. Let's say we want to put 1A and 1B in the same bank. So let's go back to the symbol order file. And what we would do is let's take out the end of that symbol and the beginning of that symbol, and we'll just put a balanced symbol sides in there instead, and we'll space it by 2. And so now on the left we'll have VCC-IO-A, on the right we'll have the I/O pins for 1A. We'll balance the symbol sides, which starts a new section in that, and then we'll put the VCC-IO-B on the left and the I/O pins for 1B. And let's change the name of this to 1A, 1B. Save it, run, build symbols, view the symbol, and now we can see we have VCC-IO-A, all the 1A pins and all the 1B pins on one body instead of split across 2. And so I can leave it as an exercise to you guys to combine banks if you want, to shrink the part and make less symbols. So we created 6 of 9 symbols, so this is symbol 6 of 9. And again, Part Builder calculates all this for us and puts that text in. It also, as you can see, it takes this name, and if I look, I didn't get that 1B in there. So I'm going to move out, save it one more time. I'm going to run, build symbols. You can see how fast it is to regenerate the symbols. And we'll view the Allegro symbol one more time. So the name that we put in the symbol description language, FPGA Gen 1A 1B, gets put on the bottom here of the symbol. So that concludes today's demonstration of using the Altera flow to create a MAX10 part. So that was a 256 pin part. That was all the steps required, and we did it in less than 5 minutes, or 11 minutes, let's say.